Hello there, my name is Matt Hastings. I'm the Deputy Director for the Ofgem Strategic Innovation Fund. And many thanks for taking the time to join us today for the Round 1 Alpha project Show and Tells, focusing on future gas digitalisation. As you may know, the SIF's vision is to deliver net zero at lowest cost to consumers. Next slide, please. And also to turn the UK into the Silicon Valley of energy. And that means we're trying to make the UK the best place in the world to be both an energy consumer and an energy entrepreneur. And our strategy is very simple. It's divided into what we do and how we do it. The what has three pillars. It starts with alignment, and that means alignment with other funders, with other sectors, and with regulatory change. It then has responsiveness as the second pillar. And this is how we set our 4 new challenges every year, and we deliver those challenges using the agile discovery, alpha and beta phasing. And finally, commercialization. And that's ensuring that projects become products and services and great new businesses can grow and scale across the UK and internationally. And this is supported by the how, which is our Giant Leap Together operating model, as the animation shows. Giant Leap Together is essentially an innovation value chain that takes the year and carves it up into 4 activities. In Q1, we focus on setting and basically challenge setting and identifying problems. And this is what the Energy Innovation Basecamp is looking at next week, which you'll hear about later. Q2, we focus on targeted ideation, really focusing ideas against those problems. And we'll be looking to set up an event to support this soon as well. And then in Q3, we focus on incubation and building consortia with unusual partnerships. And this is where the Innovation Summit comes in towards at the end of this year. And in Q4, we focus on acceleration. And this is where we launch the challenges that were identified during Q1. Working with Ofgem, we set up the SIF to deliver tangible benefits to people, the planet, and to business, and benefits that should be able to save consumers money, reduce CO2, and develop new products, services, and technologies that make consumers' lives easier. What you'll hear today are real insights into the key areas of the net zero transition. So please engage, debate, ask questions, spot opportunities, make contact, and really join us in a collective effort to try and fix the future. I wanted to say a huge thank you to all of our network leads, NGN, Cadent, and SGN, and their great partners, the likes of Synovate, Guidehouse, IBM, DNV, Amazon, and all the others that have been involved. And last but definitely not least, a big thank you to the amazing Innovate UK teams and the Ofgem teams as well for their tenacity, agility, and hard work. Innovation really is a team sport, and we don't want to go short distances, we want to go really long distances, and we can't do that unless we work together. So I hope you enjoy the session, and I'll now hand over to Beth.
Good morning, everyone. My name is Beth Foster. I'm one of the new innovation leads at Innovate UK. So today we're looking at Round 1 Alpha projects, which fall under 4 key challenges set by the SIF. They are whole system integration, the heat challenge, data and digitalisation, and zero emission transport. As you can see, data and digitalisation and whole system integration were the most popular and has been awarded the most funding due to the number of projects in the challenge areas. Next slide, please. So next slide. Yeah, the agenda for today, there are 3 projects which in today's show and tell. The first one is thermal imagery analysis by NGN. They're looking at innovation to detect leakage from within live gas-filled pipelines using a prototype sensing system. This means that they can inspect operational pipelines for leakage under several scenarios, which is crucial to help achieve our net zero targets. Following that, we have the digital platform for Leakage Analytics by Cadent Gas, also known as the DPLA. And they've been designing a platform to allow gas networks to locate and target highly emitting assets for maintenance and repair, using a mixture of drone, aircraft, and vehicle-based monitoring methods. And finally, we have Gas System of the Future by SGN. They're working on an ecosystem of digital twin networks to optimize energy network usage, whilst ensuring the security and resilience of data sharing across the network boundaries. So like me, I'm sure you're really excited to hear about all of these amazing projects. And I'm going to swiftly move on, stop talking, and hand over to Nick and Simon, who are going to start us off with the thermal imagery analysis show and tell. So before they do, I would just like to point out we have a Q&A box in the bottom of your screen. If you could add your questions and thoughts in there, that would be amazing. We will have 15 minutes after each presentation to go through Q&As. Awesome. Over to you, Nick and Simon.
Brilliant. Thank you, Beth. Good morning, everybody. My name is Nick Smith. I'm the Energy Systems Innovation Lead at Northern Gas Networks, joined by my colleague Simon Langdale, who's the director at Synovate, who are part of the Synthetech group. We're also partnered on this project with National Gas Transmission, Digital Catapult, iTouch Systems, and the University of Sheffield and the Pipebox Consortium. Could you just move on to the next slide, please? And the next one again, please. So the problem that we were trying to solve with this alpha phase project was utilising the original LeakVision platform, which was developed during an NIA project a couple of years ago, to really tackle the key challenges within the UK energy system. So as with the majority of all these projects that are running through the SIF mechanism, we're looking at really targeting and minimising our impact on climate change. We're looking to mitigate methane leakage from the network, otherwise known as shrinkage. So looking to really improve the way that we approach, address, identify and remediate leakage on the network. Within that comes reducing the cost of leakage and improving the efficiency at which we can repair escapes on the gas network. Part of this project was also identifying the way that we could use systems similar to LeakVision and the thermal imagery analysis process to really get a better understanding of our assets in the ground today, to expedite the process of transitioning to a hydrogen network in the future. There were also the challenge around improving the way that our field operatives really capture and report on data from the field, and increasing our asset accuracy in reality. If you can move on to the next slide, please. So I guess a wider introduction to the LeakVision system itself. So it's a robotic platform that we can enter into a live gas distribution network. It uses active thermography, which is a way of how we describe to excite gas within the system, which we can then use a thermal imaging camera to identify temperature changes within the system, which then correlate with escapes, points of interest, and other areas which we can then investigate and aim to repair in a more efficient manner than what we do today. It really supports you getting a clearer image and way of identifying the actual asset condition without having to excavate multiple areas in high congested streets and roadways, so that we can then do that in a more efficient and cost-effective manner. It also supports with reducing the network risk, not only from the system today, but also with predicting and assessing the way that we can utilise these assets way into the future for use with other low carbon gases as well. So move on to the next slide, please. So the alpha phase of this project, so that, like I said earlier, the actual LeakVision platform itself was developed initially during an NIA funded project, so a Network Innovation Allowance funded project. The way that we wanted to progress and really optimise this system through the alpha phase was to really enable the digital aspects of the platform in terms of being able to capture more data and share that wider throughout the business to enable different business functions to make more informed and more efficient decisions on assets. There's also a way of improving the way that we actually capture the data. So typically and traditionally what we do is use a little black book or something of the sorts, where we'd actually write down and capture asset data and then physically transport that into a systems, whereas this is now enabling us to capture it live in real time, reducing the impact of human error, but also making it more efficient and user friendly for those carrying out the work. There's also what we were looking to do is assess the way that we could potentially use either AI or machine learning to improve the efficiency at which we can make those decisions. So the way that we can use the data to inform better decision making it wouldn't necessarily be the final decision, but if we can use that sort of technology to inform the way that we deal, manage and maintain with our assets, it's a real game changer. There was also an aspect of miniaturising the system. So the original Leak Vision platform was designed for assets 12-inch in diameter and above. Throughout the alpha phase, we've identified and developed a method of using similar technology to inspect assets below that diameter, which are the ones which are really key to being replaced with the iMains replacement programme. So those in the real near future in terms of being the highest risk assets. So that's also been a potential game changer for us moving forward. We also look to the future, so we look to see how we could utilise the system within hydrogen assets. So we took a trip up to DMV Spade Adam to utilise it in a hydrogen test bed. And then there's the wider use, which we will look to assess and validate the various use cases which spun out during the discovery phase to look if we could really narrow down the accuracy and reliability of the business case for those. If you could move on to the next slide, please. I'll just hand over to Simon.
Real thanks, Nick. So I'll talk you through the work that we've done in the alpha phase. And the alpha phase has really allowed us to frame the problem that we're trying to solve in a global context going into beta, which has been really helpful to make sure that we're addressing a problem not only for the UK currently, but a problem that has a global setting that we can then look at how we would move that abroad and grow export opportunities and different types of opportunity in that global setting. And our challenge statements that we went into the alpha with have really mapped quite well across that and has given us great insight. So now we have the ability to put robots inside pipes. We can move from the paradigm, which is the current status quo of we have operatives in the field who dig holes to try and find a leak on an asset and then enact a repair. The vision that we're trying to move towards with the digital technology that we're bringing in is you can put the camera, the sensor inside a pipe, and with the granular data that we're able to capture, we can then have that one excavation be the intervention. So we move to a world away from spades and traditional excavations into a much more digital era where we can inspect, remediate and maintain the assets using robotics. And this has been a fantastic program for us to really be able to portray that vision. So what the challenge is for the UK and then for the global export opportunity in this. One of them, as Nick had mentioned, is how do we do smaller diameters? So part of the alpha program for us was working it out, is there a viable route to commercializing this and miniaturizing the technology to address some of the smaller mains within the UK and globally? So we did a piece of work and the approach was to miniaturize the Leak Vision sensor that normally sits on a platform. And what you can see in the images is we've produced what's called a push rod camera. This is a fairly ubiquitous piece of equipment. Lots of people use it. It's very commonly used in drainage inspections, but we've been able to modify that type of technology to take the thermal imagery analysis system to access those smaller mains and make it digitally compatible as well. So this works with our little red box. We can capture all the data and we can put it up onto the cloud. So that's been a phenomenal success for us. Next slide, please. One of the other key challenges that we were trying to address is we want to move to a net zero world. We want to move to hydrogen. There are unknowns and risks with that need to be addressed. One of them is how would we manage leakage on a hydrogen network? Our thesis is if we can accurately detect pipe leakage from inside the pipe, we can make interventions at a distance from that leak to keep operatives at, say, a safe distance. When there is a leak, they can then remediate the leak from a distance because they have this in-pipe technology to be able to find the leak, pinpoint it, and then deal with it. We built in a piece of work in our program to go up to DNV and test the Leak Vision system in hydrogen. And I believe this is a world's first in having active robots inside a hydrogen pipeline. So we were super excited to be up at DNV and get this test done. So this is the images from the test that we did. This is our robot inside a hydrogen pipeline. And as you can see on the bottom, we can distinguish between an active leak site and a non-active leak site. And it's the little bright dot at the bottom of the two yellow images. One has no leak and the other has an active leak. So this is a simulated road and we're simulating the conditions of what a hydrogen network might look like in the future with a hydrogen asset. We're trying to understand how it tracks through the ground and then how we can detect it with a robot. So that was a phenomenal piece of work, and we were really happy to get that done and understand that leak detection in pipe is something that could really be used for hydrogen networks. Next slide, please. One of the key themes about the work that we're doing is really to upskill and put in the hands of the operatives new technology to get that massive productivity upshift that we're going to need across the utilities to get to the net zero vision. So our vision for this is not necessarily coming in always with a service of a robot. It's how we can put that in the hands of the operatives. And we've had a small program with Northern Gas, and they've got a team that are the first team in the UK to run their own robotic inside a GDN. And it's phenomenal. One of the risks for us looking at the beta is how can we make sure that the rest of the GDNs have that ability to scale up. So we had a package of work about, can we do trials? Can we get this within the other GDNs in the UK? And we were really successful, and we managed to do 2 jobs. This is a job in Ipswich with Leak Vision going in to do active leak detection. This is the oldest gas main in Ipswich. We're really fortunate to get that. We had a fantastic success. And it really underpinned our belief that we can roll this out and we can scale this up across the UK into the other GDNs, across those different policy barriers and different approaches with the way that they work as well. So that was another fantastic piece of work that we did, and we were really grateful for being able to pull that off. Next slide, please. So one of the key pieces of what we're trying to do is get access to this granular data to make sure that leakage detection and repair can move down the learning curve and get to the lowest possible cost, so we can attract and address the most amount of leakage in this new way. So how do we capture the in-pipe data from site? We've got a platform. It's the little red box in the image, and effectively, as we do the robot or the push rod operation and scan the pipe looking for leakage, we can input lots of different data about the pipe. We take all of the CCTV, we take all of the thermal imagery analysis data, we take temperatures in the pipe, and we can aggregate that and put that up onto the cloud, so it's available for then analysis to be done. And this is where some of the opportunities for AI and ML are, where we can then optimize how we address the leakage in the future. This was really successful, and we managed to then share that from site. Next slide, please. So what that looks like, almost in real time from site, we collect all the data that's put in real time into a reporting format that can then be sent out from that red box to the GDNs, to other stakeholders, to people who need the information, and we can filter the information. So we'll show that we're only sending the information that's needed from site and not creating a data swamp. We're really trying to push and create a data lake of really valuable information for companies to be able to use. And this is what that reporting looks like. And this is the information and the kind of report pack from the hydrogen test that we did. So this is a digital report done inside a hydrogen pipeline using thermal imagery analysis, which is really fantastic for us. Next slide, please. How do we do that from the field with the end user? We've created the end-to-end digitalization requirement. So this is the pipeline of how the data moves through all the systems, and then how we can pop it out to the different GDNs and stakeholders. So that's well documented. We did a fantastic piece of work with Digital Catapult, where we were able to make sure that we were putting cutting-edge technology and standard industry practice into the thought process that we did. Next slide, please. From that pipeline, we were able to assess and prioritize where AI, artificial intelligence and machine learning can provide the most benefit and opportunity in this area. We really want to push the data digitalization, and we really want to make sure that we can do AI and ML where they're appropriate and where they add a lot of benefit for the consumer, bearing in mind, and we've got a big focus on the governance mechanisms in there to make sure that there's no black box of AI making decisions on behalf of the user. Next slide, please, and I'll hand back over to Nick.
Thanks, Simon. So, as with the majority of these projects, the key to the success and really being able to achieve the benefits associated with the work is collaboration. So one of the big parts for us was really enabling dissemination of knowledge, experience, and really allowing people to get hands-on with the system itself as it's been developed over the last few years. We held a number of events, mainly with academia and other utility partners. So we held a showcase event at DNV Spade Adam and at the iCare facility in Sheffield, which enabled colleagues from outside of the energy industry, mainly into the water industry, to really understand the potential benefits for this sort of process and instrumentation wider than the gas distribution networks. We also consulted with academia, so that enabled us to validate and assess the thesis that were raised throughout the project, enabling us to work in a more informed manner. Our colleague from Synovate, Pravin, presented at the IGM YPPC and analyse event to really share the learning and the understanding from the project with colleagues within the gas industry. We also had a... Go on, sorry.
Right, just to say as well, this has been a fantastic opportunity for us to really engage at a young age with STEM, and we've done a huge amount. Thanks very much to UKRI and Northern Gas for enabling that to happen, because that's really made an impact and been able for us to promote that. So really big on the STEM piece that we did with the Young Innovators Committee as well.
Yeah, absolutely. We held an event a couple of weeks ago at Northern Gas's head office in Leeds, where we talked with the Young Innovators Council, allowed them to get hands-on with the robot itself, really posed the question of what would a career look like in the gas industry in the future if it was to have robotics inspection enabled, you know, moving away from the traditional gas engineer and really opening that opportunity up to people of all ages, but also from all backgrounds as well. It's really fantastic for us. Next slide, please. So future outlook then, so what does beta look like? So the key for us is that the beta planning is still ongoing, and we are looking for future collaboration with other partners as well. We feel that the real benefits to be achieved from this sort of work is to really scale it up across the entirety of the networks, not just to keep it within one. That would enable rapid methane reduction across the entire system and really develop and enable efficiencies for all partners. We're looking to validate assumptions, so the business case and the CBA that we've done over the last couple of months, we're looking to, as we scale up, validate the assumptions within that and really make that cost benefit and business case more reliable and accurate as we move into the future. We're looking to obviously enhance and optimise the system. As ever, the more data that we can gather, as long as it's useful data, will then enable us to make more informed and more efficient decisions, certainly in terms of asset investment and replacement. There's a case, as Simon said, for really upskilling the workforce, so enabling more efficient data capture, more reliable data capture to again make sure that any information that we do put into our systems is the most accurate, so it can enable the most informed decisions. And then the real big one that we're looking to achieve throughout beta is being able to collect and provide enough evidence to really build utilising this sort of technology into future price control business plans. So it's great that we've really had some good trials so far and been able to capture data and prove that it is a usable system and a valuable system. But we really need to be able to prove that the business case to scaling it up into business as usual is key. So that's one of the main things that we're looking to do throughout the beta phase. I don't know if have you got anything more to add on that, Sam?
No, thank you very much, Nick. That's fantastic.
Brilliant. Next slide, please. Brilliant. Well, thank you for listening to us today. We really appreciate the time and the opportunity for presenting to you all. Thank you.
Thank you so much, Nick and Simon. I'm going to take this opportunity to kick off the Q&A. We've had quite a few questions in the chat, but I'm going to kick off with one, as my background is gas operations. So there is an ambition to increase the speed of gas through the pipelines. Would that have an impact on your sensing capability and resolution or anything of the sort?
It's a really, really good question, Beth, and it's quite a technical answer, unfortunately. The way that we get the detection with the leak vision sensor is we create a slight warming of the gas inside the pipe. The amount of warming we need to do to get a detection is a function of the amount of gas that we have to warm up. And the speed of the gas as it moves through the pipe means that there's more gas to warm up. So how that changes in terms of the detection, it means we need to put more power to the robot to allow it to warm the gas up slightly more. We've started at the bottom end of what we're able to put in, and we're building up. So we start really low. We have a sensor that detects down to 41 thousandths so 40 millikelvin in terms of a temperature change. So we're really looking at very small amounts, but we have a lot of ability to go quite a lot higher than what we are as well with how much we excite and warm the gas to get that detection.
Thank you, Simon. I'm gonna start reading out some of the questions in the Q&A. So I'll start with the first one. Will this service be offered by Synovate, or will you train NGN field operatives to use as part of beta?
Great question. So we're looking at both models at the moment. Our preference from an environmental perspective and from a doing good perspective is to really look at the upskilling of Northern Gas and the other GDNs to really implement the technology, the training and the digital at scale so we can get mass benefit, move away from spades and digging and excavators. What we're currently able to do with the robotics, and I'm talking slightly more generally, one excavation can enact currently 63 repairs, so that's a 63 times uplift in terms of per hole productivity. That, if that sits with the networks and we can achieve that, is really significant for the UK and then for export opportunities. So that's really where we're focused. It's about embedding the technology.
If I can just add on to that as well, so in terms of robotic usage within the networks, certainly at Northern Gas we already have a team that specifically uses robotic platforms for enacting leakage repair. So that's using the STAS platform, which has also been developed by Synthetech previously. So we already have a team that is dedicated to using that platform, who've been upskilled from being engineering repair teams to being robotic engineering repair teams today.
One of the great questions we got back from the Young Innovators Committee at Northern Gas was around how robots could displace jobs or create job destruction, and that's something that we're really taking on board and something that we're keen to show that robotics and automation in the field is very difficult, but it doesn't necessarily mean more jobs. We're just trying to make it mean more productivity and potentially better jobs as well.
Thank you both. Next question is, could this technology be used in other sectors?
Great question. Yes, we're having active discussions with the water companies through the Pipebox consortia in the University of Sheffield about how we can transfer some of the technology, certainly some of the learnings. We do a lot of dissemination and we're really keen to share, you know, our experience and our approach and try and grow those other opportunities as well. So there absolutely are, and we're actively working on those as well.
Thank you. I'm going to whiz through these because we've got so many now. So we've got a really long one now, bear with me. Online leak detection systems have been operational for decades, identifying the occurrence of a leak, its location and the quantity of gas leaked. In combination with regular internal intelligent pig runs, 5 to 10 year intervals for asset monitoring and management, gas pipelines have been cared for both onshore and offshore internationally. Why is such a system needed now, and how much does it cost the operator in terms of downtime, non-delivery of gas, and damage to pipeline, etc.?
Fantastic question, thank you. I'll take that one. So pig runs are typically not really done on the distribution network that we operate in due to the kind of network topology. It's quite a complicated underground maze of low pressure pipelines within the UK. One of the issues and the opportunity that we found for Leak Vision is leakage detection has been done a lot on potable water side with the UK water companies, and they've had some really great successes over a number of years in reducing leakage. The way that works is they use acoustic leak detection. Acoustic leak detection technologies don't work at the low pressure that the UK gas network operates at, so you can't physically hear a gas leak from the inside of a pipe. So there's a missing piece of technology. The Leak Vision sensing is that missing piece of technology. We can see the leak at low pressure. And the idea is if we have that keystone piece of technology, we're then able to have that same transition and same up in performance in leakage detection across gas that is starting now and moving through the water networks.
Yeah, there seems to be a lot of crossover into water as well.
Yeah. And everything's live as well. So there's no downtime for the asset. The robot and the camera systems are inserted live into the pipe, so the customers are never interrupted. We can put the technology in, we can scan, we can find the leaks, we can repair the leaks with no downtime at all or interruption to the customer from a single excavation.
If I could just add to that as well. So the way that we typically respond to gas escapes on the network is that a member of the public would ring an escape into the National Control Centre. A first call operative would then attend site, safeguard life and property, and then try and locate and programme the escape, be it in the footpath or in the roadway. A engineering team would then come and typically excavate onto the highest reading, wherever that may be, in a footpath or in the middle of a four-way junction. The aim of Leak Vision is to initially look at, can we enter that network from a more, a less disruptive position, so potentially in a footway or potentially in a grass verge, enter the network, identify where the escape is, and then allow for the least disruptive repair method to be enabled. In reality, the way that we want to progress to, really the end goal of this is to have proactive leakage inspection, so that we've got a set of these instruments operating within the network proactively to identify areas of concern before they actually turn into escapes on the network, completely eliminating the risk entirely.
Thank you, Nick. I'm going to move on to the next one. I might have to reword this one slightly. Do you have an estimate percentage of leakage? And does that how do you word this one? And how have you addressed the impact of the application of this technology on greenhouse gas emissions?
So greenhouse gas emissions from the UK distribution network equate to approximately 1.6 million cars worth of traffic taken off the road. So what we're looking to be able to do with the robots is really address that. If we can make the intervention more carbon neutral as well, and what I mean by that is we can do 63 repairs from a single excavation. The excavations in themselves, the operation, the planning to get there, all have a carbon footprint. If we can automate and really boost the productivity from that single intervention on the network, we can make a massive dent, I think, on that carbon footprint of not only the leakage at the 1.6, but then the carbon cost of the intervention as well.
Thank you, Simon. Okay, the next question. To clarify, is the project making adjustments to the device now so it can be used in hydrogen? If not, would this require significant alterations?
Great question. Thank you very much. So as part of the beta program, we're looking at the implementation piece, which has got an amount of the certification requirements. We're looking at the hydrogen standard. The work that we've done to date, we've tested both hydrogen and natural gas, and we'd work to the worst case to make sure that we have opportunities for both. There's not too much variance in what the standards and the commercialization would look like for that. And in terms of the detection mechanism, it works in both hydrogen and natural gas. The gas characteristics are different, but they kind of balance out in how they're different to allow the detection to work across both.
Thank you. So the next question is slightly less technical and more, I guess, of an opinion question. It was really interesting about the young STEM engagement that you mentioned in your presentation. Perhaps a wider question, but how do you think SIF could bring in younger people and views into other projects? And did you get any interesting insights from your engagement, which you previously didn't think about?
Yes, and if somebody who sent this question would like to reach out, I'd love to engage with you on this a lot more. I sit on the West Yorkshire Combined Authority Committee for Business, Innovation and Economy, and there's a join up there as well about what we're trying to do with Place. So we've been using this Alpha as a little bit of a platform to really sell the North as the place for innovation. That's really a passion of ours, and but doing that by engaging young people about what their innovation requirements, what entrepreneurship looks like, what STEM careers look like. This has been a phenomenal platform for us to be able to do that, and we've had some really great success. So I'd love to kind of tell you more about that in detail and look at opportunities to be able to share that further, because I think it's been genuinely really powerful.
That's great to hear. We've only got 4 minutes left for the rest of this Q&A, so we'll try and get through as many as we can in the next couple of minutes, but apologies if we don't manage to get through all of them. Do you have any quantifiable information on the improvements witnessed during the new tech, i.e. the percentage reduction seen was X, and what would be the net cost benefit? I feel like this ties into a previous question we've already asked.
Yeah, so we've got a very detailed benefits tracker that we're putting together as part of the beta program. It depends specifically on which elements we take from the benefits map, that everybody will be aware of, and how that drops through into then commercial delivery as well. A lot of the benefits come from carbon mitigation, but there's also a number of societal benefits as well. So we're just trying to work out which one of those we pick up and drop into the current format for the beta and that benefits case as well. There's a lot of savings. There's savings that are really easy with the Green Book values to be very articulate with, very tangible benefits. Leakage reduction and the methane emissions is huge. It's a really significant one. There's also a lot around stranded assets. So if we're able to life extend a lot of the tier 2 and tier 3 pipe out up to, depending on where we take the date, 2038, the West Yorkshire's got an ambition to be net zero, 2050 maybe, we can life extend that. We're not going to be left with stranded assets in doing replacement on assets that might end up then not kind of seeing a future if we don't get the hydrogen, and we're working against both of those cases. There's also a lot of more anecdotal benefits. One of the jobs that we did recently, by being able to identify the position of the leak and then treat that leak remotely with robotics, we were able to save an estimated probably £1 million on a single job. Now, this is a very highly urbanized area in a very high profile region of the country, but they are the distribution of savings that we can get. Some of the jobs can be very, very expensive when you take into account lane rental charges and impacts to buildings and infrastructure.
Yeah, if I could just add again there, sorry. So I think that the key here is that the immediate use case for us is using this system and this technology for leakage detection and repair, you know, to enable rapid decarbonisation of the system today. But there is also the other use cases, as Simon's pointed out there, around asset management and ensuring that if there are areas of the network which will look to be decommissioned in the future, how do we manage those safely and effectively without creating additional cost for both the network and consumers? I think that the way that we can potentially deploy this in the way that the benefits can be scaled up is around cost avoidance as opposed to real cost saving.
Thank you. Now you mentioned assets just then, and this ties into the next question. As well as leak detection, could the data support an increase in asset useful life assessment?
Nick, do you want to take that one?
Yeah, sorry. Yeah, absolutely. So the way that we really look to utilise the system, like I said today, is the trials that we've done has been on active leak sites, so where we know there's been an escape. What we want to do is really prove that moving forward, the data that we capture from using the system on a part of the network which potentially doesn't have an escape on it, more so just points of interest, how we can then ingest that data and really support better informed decision making within the business for the likes of the investment management teams. So the way that would work is, again, really using the information and the learnings from the alpha phase in terms of how AI and machine learning can be applied to that data, and enabling those to be ingested by the business to really inform how we can then use that information to better manage the assets into the future.
Thank you, Nick. Thank you, Simon. That's the end of our Q&A session. I'm afraid that's all we've got time for. But if anyone wants to reach out, I'm sure there will be contacts available if that is the case. I'm afraid I'm going to have to move on to the next show and tell presentation. Thank you so much. And we are now welcoming Anne and Magali from Cadent and Guidehouse for the digital platform for Leakage Analytics. Over to you.
Thank you, Bethany. Good morning, everybody. Welcome to our presentation on DPLA, or the Digital Platform for Leakage Analytics. My name's Anne Ward. I've been the project manager throughout the alpha phase of the project. I'm joined by Magali Aran today from Guidehouse, who's our delivery partner. And we'll be taking you through the background of the project, the problem it's addressing, and what we've achieved throughout the alpha phase of the project, and then we'll be discussing the next steps behind DPLA. If you could move over, sorry, can I go another one as well, please? Thank you. Okay, so what's the driver behind DPLA? Well, DPLA has significant impacts on social and environmental, consequences and that relates to the gas emissions from our networks. So there's some numbers here on the slide. So in 2021, for example, the amount of gas lost from the gas distribution networks amounted to 2,330 gigawatt hours, and that was at a massive cost of £115 million. This is an extremely significant figure there, and it represents roughly 1% of the total UK greenhouse gases, gas emissions. So the global warming impact because of the methane has a much higher global warming potential than carbon dioxide. As you are aware, the UK has pledged to reduce its methane emissions by at least 30% by 2030. So this is an important issue for us to tackle across the country and help the country meet its objectives. And then, as you are probably aware, the cost of all of this is passed on to consumers through their gas bills. And in the current climate, obviously, that it is also a negative impact as prices have dramatically increased. So the scale of this issue is likely to increase should we make the decision to transition to hydrogen gas. And the government is aiming for hydrogen to be 20% blended by 2030. So obviously we need to address this issue very quickly. Completely eliminating leakage from gas distribution networks would amount to removing nearly 800,000 petrol cars from the UK roads. So to achieve this, we need to further understand gas leakage, and then that will enable us to form a plan which we can then look towards reducing emissions effectively. Thank you, Magali.
Thanks, Anne. So how does the DPLA come into this? So it's a collaboration between all UK gas networks, including all 4 distribution networks, as well as national gas transmission, and is being led by Cadent. The concept is for a digital platform which will use novel gas sensing technologies combined with machine learning and hybrid hydraulic models to drive a complete step change in how the gas networks quantify, understand, and report on leakage and emissions. So currently, at the top of the slide there, you can see that shrinkage is reported on an annual basis using the shrinkage and leakage model. And this takes data about gas network assets, such as pipe length, diameter, and materials, and uses leakage factors based on previous experimental national leakage tests to calculate total leakage in an Excel model. So that's the kind of top gray box we have there. Now, the DPLA will take a much more advanced and innovative approach. We still have asset data, you can see in that same dark orange box, but it will also take in operational data from the network systems, including pressure, flows, and temperatures. And in purple, we have a new data source that will be generated by DPLA, which is coming from innovative in-field leak measurement technologies. So things like helicopters, drones, or cars equipped with gas sensors, which travel along the network, detecting and localizing leaks. And this data will feed into a number of modeling tools, help to train the machine learning algorithms, and all of this will feed into a rule-based expert system in the green box, and this translates all of the kind of information into something that can determine the actual likelihood, location, and size of leaks. And then finally, this information will be made available through a user interface, which is that final orange box, which allows the user to view reports and maps for different time periods and different regions, so at a much more granular level than the current model. Next slide, thank you. So what we achieved in the alpha phase is summarized on this slide here. The alpha phase analysed and produced recommendations for many aspects of the DPLA. And if we start on the left column, at the core of this was the system architecture and design, which you can see kind of a little graphic of there. And it's essentially the technical design for the platform, which will be hosted in a cloud service provider platform such as Amazon Web Services. Next, we had technology recommendations. So over 20 in-field leak detection technology providers were analysed through interviews and case studies. And this allowed us to narrow it down to a shortlist of 7 to be recommended to be put forward and considered in beta. And I'll talk through these in more detail in a later slide. Moving to the middle column, another important aspect is the change impact assessment, so business change. Of course, this kind of step change in process is going to have significant implications for the business, and so adaptation strategies were identified for 4 categories. The first being job roles, people and skills, the second being processes, third is systems and tools, and finally behaviors and attitudes. And then that brings us to also the regulatory impacts that need to be considered. So here as well, there are 4 key areas which will likely be affected by DPLA. And these are asset management, regulatory reporting, regulatory outputs, and the shrinkage and leakage model that was mentioned previously. So discussions with Ofgem were already initiated in the alpha phase, and we plan to continue to work collaboratively with them in beta to figure out the way forward from a regulatory perspective. From an economic perspective, a cost-benefit analysis showed that the DPLA could have a net value of up to 2.8 billion to 2050, and that this could remain positive under different sensitivity scenarios and timelines that we tested. And finally, moving to the right column, throughout the alpha phase, we engaged with various stakeholders to inform them about the project and gather feedback about it. There were several kind of groups of stakeholders we engaged with. So firstly, Cadent customers who we reached out to through a survey to get their opinions on this concept. Then we had gas industry stakeholders, including the Shrinkage Forum, through which we engaged with gas shippers. We also spoke to customer stakeholders, citizen groups like Fuel Bank UK and Citizens Advice. And finally, we also spoke to sustainability bodies such as the Environment Agency. And we've had a lot of positive feedback, as well as a lot of useful inputs that are helping us to shape our beta program right now. Finally, the alpha phase analysed different commercial models for the platform and recommended options for the building, marketing and ownership of the DPLA, and these will be further evaluated in beta. Next slide, please. So through the alpha phase, the kind of key use cases were reviewed from discovery and refined and developed in collaboration with all the gas distribution networks. And these are kind of the key use cases that were identified. There are a few others, but these are the ones we'll be focusing on at the moment. We can group these into 3 key types and capabilities. So firstly, we have operational use cases, which relate to the way the networks run and manage their assets. This includes proactive emergency intervention and condition-based monitoring, which would improve the understanding of the state of the network assets. Then we have business use cases, which relate to the way networks expend their CapEx and REPEX, and include things like asset replacement and maintenance, scenario forecasting for network planning scenarios, that sort of kind of more forward-looking things. And finally, regulatory use cases relate to the network's regulatory obligations and how they meet their license conditions. And that's things like regulatory reporting, procurement forecasting, regulatory performance, and retrospective modeling to set baselines for things like emissions. Finally, in green, you can see that user requirements were also defined, and these relate to more practical aspects of the DPLA's functioning, things like user access, controls, and user experience. Next slide, please. So, as I mentioned previously, we shortlisted 7 technologies that we want to look further into in beta, and these were selected based on their current maturity, cost, practicality. And we have a short list of 7 because we expect it's not going to be one technology fits all. We'll need a mix to cover different assets. In particular, the assets have been grouped into pipelines split into rural and urban pipelines, and AGIs, above ground installations, which are things like compressor sites. So if I take you through these briefly, just so you get an idea, like a bit of a taste of the things we're looking into. Firstly, we have Picaro, and they're a car-based technology where they have operators that drive the network and detect leaks through a gas sensor that is installed in the vehicle. We also looked at OG Charm, and this is a helicopter-based LiDAR system which flies above the pipeline and detects leaks as it goes. Project Canary is a type of fixed sensor that's really appropriate more just for AGIs. So these are sensors that would be installed at sites and will monitor for leaks continuously. Seek Ops use a similar technology, but they are drone-based, so that would not be continuous. It would be something used to do periodic site surveys, say like once a year, where a team goes out, flies the drone around the site and identifies any leakage hotspots. Cube are a different type of fixed sensors, also for sites, but again, that will be installed at sites and monitor continuously and send kind of alerts in real time if any new leaks are detected. And finally, the last 2, sensors and Teledyne FLIR, are for a slightly different purpose, which is kind of last mile detection. So when any of the above 5 have spotted a leak, we could use one of these high flow samplers or optical gas imaging cameras to go to the leaking asset and really pinpoint exactly where the leak is coming from and how much it is leaking. So as I said, this is kind of a fast moving area. There's a lot of innovative new technologies being developed. So this is a short list for now, but we will continue to kind of assess and review this for new technologies and developments throughout the beta phase. Next slide, please. Thank you. Yes, so we performed a detailed cost-benefit analysis and found that the DPLA could deliver up to 2.8 billion in net value, as well as 15 million tonnes in carbon reductions by 2050, and that's including all the UK distribution networks. This took into account the cost of building the platform, deploying all the hardware that's needed, such as the technologies I just discussed, rolling out the DPLA to all the networks, and then maintaining and operating the platform. In terms of the benefit streams considered, we factor in the value of the gas saved through reduced losses, as well as the value of the greenhouse gas emissions avoided. There are a few other important qualitative benefits which we identified. These are accelerated decarbonisation, increased customer benefits through reduced shrinkage costs, which directly impact their bills, improved safety through proactive leakage identification, and reporting benefits through more granular outputs, real-time inputs, and increased accuracy. With that, I will hand you back to Anne to wrap up.
Would help if I am muted, sorry. So thank you, Maggie. So what happens next? So we've finished the alpha phase now, and we're busy in the background working with, that's Cadent, working alongside Guidehouse to prepare the beta application. It's being designed and it will include scope, outputs, and the resources that will be required to run beta should we be successful. The aim of beta is to deliver a functional prototype of the DPLA and multiple leak detection technology pilots, and to build a confidence in the regulatory, operational and commercial aspects of the platform. So if we were successful in securing the funding, DPLA beta phase will kick off in August 23, and we're currently estimating it will last around 3 years. During this time, the MVP will be tested on Cadent and possibly other distribution network systems, and several leak sensing technologies that Magali has just discussed will be piloted. Following the beta phase, is expected that a full commercial version will be available and developed and deployed across all GDNs and possibly transmission. So lots of hard work going on in the background to secure our beta bid, and that ends our presentation. So we'll hand over for any questions, should anyone have any. Thank you very much.
Thank you both. That was a great presentation. I'm going to kick off the Q&A with a quick question. So it seems that you're collecting a lot of data to facilitate this work. Is there any sort of analysis, transparency around sustainable data usage, the carbon footprint of data storage and processing and things like that?
Good question, Bethany. So not explicitly, I think there is a lot of data involved, but a lot of it already exists. So a lot of it is data that the networks already have, but aren't utilizing fully right now. So in that perspective, like there's not that much new data generation. The new data will come from the kind of third party in fields kind of leak detection aspect, and that can be quite will generate large volumes of data, but we don't kind of foresee that being a major issue, but that's something we could definitely look further into.
Awesome.
And just to add to that, Bethany, hi, Amir just working on the DPLA project with Guidehouse as well. So clearly there will be some emissions from a drive around vehicle or potentially a helicopter, but we did a very sort of back of the envelope calculation which tells us that our CBA is still positive in terms of the net carbon emissions avoided from those technologies. So we have considered the emissions from new data acquisition as well.
Thank you, Amir. Okay, I'm gonna jump into the Q&A chat box now. So how does the DLPA project tie into other SIF projects like thermal imagery analysis or intelligent gas grid?
That's a really great question, and we have had the pleasure of having several conversations with both of those projects over the course of Alpha, and we plan to kind of collaborate with them on beta as well. So yeah, for example, the thermal imagery kind of leak vision project in particular is an example of something that could kind of work really nicely with the DPLA as kind of another data input to the wider kind of platform. And likewise, we could share data with them as well to help them improve their processes. So we're really excited to kind of create a joint work stream with them for beta. And we're working on doing something similar with intelligent gas grid, seeing how the kind of system we develop can be interoperable, and how we can kind of share data with each other to make sure that they enhance each other.
Thank you. It's nice to see that crossover between the SIF projects as well.
Yeah.
So the next question, what is the potential for using such models and systems as the network moves towards hydrogen?
Excellent question. Yeah, what's really exciting about this is that everything from the kind of modeling side, so the hybrid hydraulic model, the machine learning algorithms, these are all kind of completely applicable and transferable to any gas, be it methane, hydrogen, or a blend of the two. So from that perspective, that kind of sets that would set the networks up really nicely for the future, because it will be able to handle whatever kind of is flowing through the networks in the years to come. From the perspective of the in-field leak detection technologies, not all of these are currently capable of detecting hydrogen. This is something we've been asking every single provider that we've spoken to, and a lot of them can't currently do it, but they are definitely thinking about it, and it's something that they're planning to add to their roadmap as they start to see increased market demand. And there are a few of the technologies which are already capable of detecting hydrogen. So that's an exciting space to kind of watch.
Definitely is. Thank you. I'm going to move on to the next question. How are you planning to make use of the latest optical fiber systems in your strategy? These offer real-time monitoring, which brings integrity management into the digital age. And that was posed as a question.
Yeah. So as far as I'm aware, optical fiber is something we looked at in the discovery stage, but that we decided not to take forward. And I believe that was due to the fact that it's quite difficult to install retrospectively. So it's quite good for new pipelines because you kind of put it in at the same time. But for existing pipelines, it would be a lot of work and a large kind of investment to add that in. So it's not something we're actively considering at the moment.
Thank you. We have another question. It sounds like data is key to this platform. What are the plans for data sharing between GDNs should the platform be commercialized and rolled out?
Good question. Amir, do you want to answer this one?
Yeah, sure. So I think it's something, all of the GDNs are going to continue to be project partners through the beta phase. So as we acquire and sort of the data sets become more mature and the models become proven, there's still a discussion to be had as to how that data can best be shared and utilized across the GDN. So I think it's still a question mark at this point, but there's definitely a willingness to collaborate between the GDNs from what we've observed as a third party. So that's really a good starting point to sort of a fully scaled up commercialized scenario.
Awesome, thank you. And we have another question. Is there the potential to pilot an innovative pipeline system designed for hydrogen service with integrated leak detection sensing as part of the beta phase?
That is not currently something that we've considered within the scope of our beta phase. Right now, it's really focused on getting the current design to a minimum viable product that would be able to then be rolled out. I think it is a lot of work and a lot of effort to kind of especially gather all the data, make sure that there's kind of appropriate data pipelines and data processes in place. So that's really going to be the focus of beta at the moment. Hydrogen is something that we will continue to kind of consider, and we want to make sure that what we produce is kind of hydrogen ready, but it's not going to be kind of the main part of the beta phase.
Thank you very much. I'm just going to check if there's any more questions. We have 5 minutes for any more questions if anyone wants to rapidly type them into the Q&A.
Beth, there's a couple in the chat. Can you read them, please? Thanks. Sorry, I can't get them transferred over.
Sorry, I don't have good visibility of the chat. Let me see. Here we go.
There's 2 to the bottom of the chat. One from Suji and one from Simon Stromberg.
Oh, I can't see the last one. Chris, would you mind reading them out for me, because I can't see them?
Yeah, sure, no worries. So the one from Simon is, there are quite a lot of papers on carbon budget of data, and it is in the grand scheme of things, it's tiny. But as stated, the main impact will be data collection. Most data centers have now co-located renewables, i.e. Amazon. I think that's more of a statement than a question. And the next one's from Suji. Is there the potential to pilot an innovative pipeline system designed for hydrogen service with integrated leak detection sensing as part of the beta phase?
I think I did spot that one, and I got that one, but if there's anything else you want to add on to that, then feel free.
No, thanks.
Okay. Awesome. In that case, we're running a couple minutes ahead. Thank you, Chris, for helping me out. Yeah, as Chris said, if you could use the Q&A function, it's easier visibility for me. We're going to move straight on to the next show and tell. So thank you so much, Anne and Magalai. We will speak to you soon. Thank you very much.
Thank you.
And we are now welcoming Peter, Erwin, and William and Dan for the gas system of the future. You guys on the line?
Yeah,
yes, we are.
Brilliant.
Yes, hi Beth. Thanks, I was on
Hi.
mute there. Sorry about that. Yeah, so thanks. So yeah, I'm Peter Phillip, Enterprise Architect at SGN, and I want to talk to you today around the gas system of the future digital twin project, along with colleagues from IBM, DNV, in AWS. So next slide, please, Beth. So next slide, yeah, carry on. So I guess, as we're all aware, the energy system is extremely complex in the UK right now, and it's going through unprecedented change. And that rate of change is going to accelerate as we drive to decarbonise. So we believe this is going to bring about a more complex energy system with greater decentralisation. With such a system, our energy sources, whether that be natural gas, electricity, or hydrogen, will be tightly interlinked and be dependent on one another. So I guess the question really that we're trying to ask here is, how do we manage, optimise, and ensure security supply across the decarbonised and decentralised whole energy system? So I'm going to hand over to Will now, who's going to take you through the next few slides. Thanks.
Next slide, please. Hi, everyone. Thanks for joining today. I'm Will Osborne. I'm a Senior Innovation Consultant here at DNV in the Growth Innovation team. And my role in this project was delivery lead from DNV's side. So this alpha phase project actually started from the combination of two discovery phase projects, both led by SGN, one looking at hydrogen production digital twin, and the other a gas network digital twin. And late in the beta phase, in the discovery phase, we had a discussion between the two teams and decided that it would be best to go together as a single alpha application, which we did. Next slide, please. So with this, during the alpha phase, we utilised IBM's value engineering methodology, which basically splits the task into some defined steps. The first is to kind of explore the total problem as a whole, which resulted in 16 epics, 43 features, and 57 user stories, which was way too much within the 6 months. So we focused in, and during the second phase of this, we looked at 3 epics, 3 features, and 7 user stories, which we broke down into 3 sprints and 3 playbacks to make sure we were always in line with the initial user stories we created. We also used the data ecosystem mapping methodology from the ODI to create data ecosystem maps for the 3 use cases we considered. And these basically show data flows in an easy to digest manner and allow us really to translate our story and tell it quite easily. Next slide, please. Along with this, we utilised some of DNV's assurance frameworks to ensure quality throughout the project. Most notably, we considered on data quality, RP 0497, and the qualification assurance of digital twins. In the data quality space, we utilised the recommended practice to create a data management policy, which outlines data used currently in the alpha phase, but also looks ahead to the beta and sets the standard for what we would use going forward. And similarly with the qualification assurance digital twins, we looked at things around organizational maturity and the rollout of new technologies in these current sectors and how we tackle the maturity of the digital twin going forward. So again, considering the alpha phase and what it might develop into during the beta phase. Next slide, please. So we considered 3 key personas during this alpha phase. The first is Roger, who's a high pressure network manager, and he actually works at SGN. And his role is basically looking at day-ahead gas demand and then ordering that gas demand from the national transmission system. And one of the problems he faces day to day is the usage of gas-fired peaking plants, which are brought online by the electricity system operator in order to meet the electricity demand of the day. And currently he has no insight into when they come online, where they are positioned, and how much gas they're going to need for what amount of time. So we had the idea to create a tool that might allow him some insight and visibility into the operation of these peaking plants for him to better predict day-ahead demand. Secondly, we had Alex, who's a H2 production manager, and their role would be around optimization of a H2 production facility. At the alpha phase, we used the H100 project as a use case for this, but this applies to any localized production of hydrogen. And the aim here is to produce hydrogen in an optimized manner. In our case, we chose cost optimization while meeting demand. So we took into things around renewable resources and production of electricity, from renewable resources, and then backing that up with storage capacity and grid electricity where needed, and optimized for the lowest cost of grid electricity. And finally, there's Helen, who's a local authority planner. And Helen's role she's responsible for the local authority in terms of planning future developments. And as part of this, she has insight into the utilities in that area. And currently, if she needs to have insight into how much capacity there is in the network, it's quite a manual process to get in touch with the relative parties, whether it be the gas distribution network or the developers themselves. And the idea we had was to create a tool that would allow her to do some initial checks on the utilization of the gas network for a certain demand before contacting the gas distribution networks. And I'll hand over to Owen.
If we could have the next slide, please. Thank you. So I'm Erwin Frankschulz. I'm the industry architect for energy, environment and utilities for IBM Consulting, and also led this project from our point of view. So Roger, as Will has just said, he needs to balance the demand that he gets. Now that is quite relatively easy. I say that, Roger would probably be upset if I say that, but he's got good tools at least to do that. For example, domestic demand, our DNV provide a forecasting tool that quite accurately forecasts how much gas we're going to use to heat our homes. And large industrial customers tend to nominate how much they're going to use the next day. But these peaking plants, by their nature, are dispatched at short notice. That's why they're so valuable to the ESO, in that they can be dispatched at relatively short notice. The challenge for Roger is that they are not connected to his telemetry system, and the ESO does not notify the gas networks of the dispatch of these plants. So really, the first time the gas networks currently see these gas plants being fired up to produce electricity is when they see that their consumption is higher than demanded. And so one of the key criteria we used in selecting from those large number of epics that Will pointed out earlier to the ones we actually developed some POCs, some proof of concepts of, was looking at integration between energy participants, actors in the wider energy system. And this was a really good example of where some information from the ESO, when they dispatch peaking plants, could help Roger plan better and update his nominations to the NTS system earlier. So that's what we did. We didn't really get to, so by the way, all of this is real software running in an AWS environment, but it's a sandpit environment, so we don't have any external real interfaces. So we simulated all of those. So we simulated what an interface to the ESO would look like, where the ESO would nominate the dispatch of a peaking plant. And then redid the calculation and alerted Roger if any of that resulted in exceeding, within certain parameters, his nomination for the day. And we visualized that using a GIS user interface based on Esri, ArcGIS, and I'm not going to go through all of those pictures, but that gives you an idea of what it looks like. So Roger can see both where the peaking plants are and also the overall contribution to the deviation of his total nomination for the day. I think that's all I was going to say on Roger. If we can move on to the next use case. So this is Alex. So unlike Roger and Helen, Alex doesn't exist because the 5100 plant is under construction. So there is no production manager yet. But the challenge that we saw for any such production system, and I think Will already alluded to the fact that we are using the 5 hydrogen production system as an exemplar, but this is a generic problem, not just even for hydrogen production, but also for potentially other gas production. So this is green hydrogen, could be similar concerns arise with blue hydrogen production, and biomethane production probably has very similar challenges. So the challenge here is that Alex has to select from multiple electricity sources. So Alex is, in this case, the 5100 project is connected to a wind turbine, a real wind turbine that is managed by the ORE catapult, and that provides intermittent electricity. Alex also has storage tanks, as can be seen in the 3D visualization at the top. And now Alex needs to decide when and how much hydrogen is going to produce to meet the demand as forecast again by DNV's forecasting tool that forecasts the hydrogen that will be required given the premises types, the 300 homes in this case, that are supplied by this dedicated hydrogen network. So on the top left we can see a dashboard. So this doesn't really give Alex much more than probably his SCADA system would give as well, but gives a view, and ultimately we didn't quite get around to that. Ultimately those tanks will be colored green to show how much hydrogen is actually stored in them. Currently we just have figures showing that. But the interesting bit happens in the next few graphs. So the first one kind of shows on the left, top left of the bottom left set of graphs of the bottom left screenshot. The top left graph shows that the wind production in this case is going to go down to 0. This is probably due to some preventative maintenance being carried out on the wind turbine. We still have a need to meet the requirements, and we've got price forecasts on that on those graphs as well. And then when we move just to the right of that one, we see that the model now suggests that the orange line there in the top of the graph, that you should start producing hydrogen with grid electricity to augment or to replace the lost production from the wind turbine electricity. This is, as Will said, this is a mixed integer programming model that does that optimization, which takes into account some of the characteristics of the electrolyzer, which can't just be turned on and off. So there's damping in it, so we can only ramp up or down by a certain amount. The electrolyzer can't produce between 0 and 15%, so you either have to switch it off or keep production above 15%. So all of these parameters have been taken into account when modeling that. Now that kind of gives Alex a production plan. We are not currently intending to link that directly to SCADA, so we still see a human interface between the two. But the more interesting thing comes when we start playing what-if analysis with this tool. So at the moment, the storage is sized to provide a week's worth of hydrogen for the 300 homes based on the worst case consumption day in winter. But what about other days during summer or even milder winter days? Could you then be less conservative with how much hydrogen you have to keep in storage all the time? And how much benefit can you get by playing the electricity market on either waiting for the wind turbine to pick up again because you know that there's more wind coming, or to wait for the electricity price on the grid to dip so that you could buy cheaper electricity to fill up your gas reserves, your hydrogen reserves once again. So the cost curves on the top right-hand graph show the cumulative cost and how much you could potentially save by playing the electricity market and optimizing that. So that's Alex, and we can move on to the next one, the last one. So that's Helen, local authority planner. So Helen is actually a real planner in the GLA, and she has the challenge that government tells London that they need to build X thousand houses per year, she may have some light industrial she needs to build as well, and so on, some other buildings like schools, other premises. The question is, where does she put them? There are lots of areas where she could potentially put them, but there are loads of services she needs to take into account when doing that. Quite apart from land use, she needs to make sure there are adequate transportation links, that there's electricity available at a reasonable cost from the distribution network point of view. There's highways, England, and transport in general. And one of the things she needs to take into account is how easy it is to supply gas, assuming she wants some of those premises to connect to the gas network. And again, this is an Esri-based tool that we built, which allows Helen to nominate an area, then specify what properties, what premises will be in that area. So she can say so many houses of this type, a school, maybe a doctor's surgery. Then we calculate the gas demand based on certain metrics. Esri then finds the shortest or the cheapest rather route. So it's got kind of cost calculations. So going along roads is cheap. Going across property where you need way leads is more important. Going through buildings is extremely expensive. Crossing rivers is extremely expensive. So it finds the nearest point to a connection point on the network. And then we fire off a DNV model that calculates for that segment of the network with that additional demand that would be generated by the premises that Helen nominated, whether that part of the network could deal with that additional cost or not. What we don't do at the moment, again, this is something we could expand to, is if the answer is no, the network can't cope. Clearly, we could look at other connection points, higher up the pressure tiers within the network, for example. But again, this is a demonstrator to show what can potentially be done. So that's Helen. And if we can go to the next slide, please. I'm going to hand back.
Yep. Hi, it's Pete Phillip again. Please accept my apologies. I'm going to leave my camera off because my machine is running like a bit of a dog at the minute with the camera on, so I'm going to leave it off. So looking ahead, we are busy preparing the beta phase submission as we speak, and we're pivoting slightly away from gas system to energy system, where we will build a holistic energy system digital twin. And we're doing this really because, as we've mentioned, we're facing significant challenges to decarbonize. In many of those challenges, we will require whole system modeling, optimization, connectivity between network systems and the underlying data streams. We're going to integrate and work closely with the energy systems of connected digital twins, and work closely with the ESO to provide that use case. We also are also looking to bring in a number of other JDNs onto the project partnership at this point, to bring in a beta, as well as some DNOs as well, because there's quite a clear crossover and balance between connected twins here, and we're looking to bring some academia in to support us on the project. We are looking at it being a 3-year project in the beta phase, and we're purposely doing that to align with the price controls. So the 3-year project should come to an end as we come in line with the JD3 price control, and we can then move that into BAU and move the ramp up and the productionization of this into BAU funding at the end of the 3-year period. The 4 key themes that we're building for the beta phase, and I'll just mention them very briefly in the interest of time. So the 4 key themes are around gas network supply management, so that's interfacing with the ASO, looking at how we better model difficult to predict demand, such as peaking plants, and alternative gas such as hydrogen. The second is H2 production and storage. So how do we balance demand and production to produce the lowest cost hydrogen with the least carbon intensity? Third is a bit of a pivot on the Helen persona, and this is around hydrogen and biomethane injection strategy, actually. So turning it from outputs to inputs to the network. So how do we identify the optimal place to site production facilities, using many data sources and models from heavy industry, electricity, gas, water, proximity to wind farms, to name a few. And the fourth key area is system resilience and restoration. So that's all really about surfacing data and models in near real time to help actors across many sectors, such as local authorities, governments, emergency services, other networks, and helping them respond faster and more efficiently during incidents. And that's the end of our presentation today. Thank you.
Thank you all very much for that very insightful presentation. I'm conscious of time, so I'm going to jump straight into the Q&A box. Pete, I am aware you did touch on this towards the end of the presentation, but how does this project, Gas System of the Future, align with the National Grid Virtual Energy Systems Digital Twin project?
So I'm actually going to ask Graham if you would like to respond to that, as Graham's been very deeply involved in that relationship. So Graham, could you respond, please?
No problem, Pete. Yeah, happy to. Hi, everyone. Graham Fraser, DNB. So we've actually spent an awful lot of time working very closely with the ESO, and hopefully some of our ESO friends and colleagues are on this very webinar. One of the things that we've really tried to do throughout the entirety of our 6-month project is to not reinvent the wheel. So look at existing projects that are in flight, either through SIF or NIA, or projects perhaps that have completed prior to the formation of either of the 2 discovery phase projects that Will shared and presented. We're really mindful there's been some great work to develop common frameworks and effectively use cases within this concept of the virtual energy system by the ESO. What we've had a lot of candid discussions around with ESO is actually providing what I would call, in that high level, gas industry use cases. So there's some fantastic power system narrative and use cases hooked into the virtual energy system. We were really keen to, I'm going to use the term, provide some balance and provide some really strong value adding gas industry use cases. And those effectively are the use cases that Owen and Will talked you through earlier. The plan moving forward is to effectively provide a series of real solutions, digital twins, that will ultimately connect to each other via the concept that is being developed and will continue to be developed by the system operator. So I think for me, the opportunity to build a product and a solution that can connect to each other, can exchange data either via API, that can use standard ontologies or models like the Common Information Model, and ultimately connect all of that via the concept that is being built today by the ESO, but ultimately will evolve into a solution that could potentially be used and adopted by a future system operator, is absolutely paramount. So what have we done today? Well, just last week, actually, we published a white paper. So this is in the public domain. We socialized it on LinkedIn. If you're interested, hop onto LinkedIn. You'll see a white paper that all of the parties involved in this project and the ESO wrote, which described how these use cases will evolve and integrate with the virtual energy system of connected digital twins. We've pushed that into the public domain. I think it's really important that we do that. It raises awareness of this balance that I think digital and data very much need against the context of those use cases. And we will work closely together moving forward. So we hope the ESO will very much continue to play a really key role on our project moving forward, whilst we very much intend to provide a series of great use cases with real products that will connect via their effectively their digital backbone. So that's a summary.
Thank you, Graham. I'm going to jump straight to the next one. How does this approach take into account the LAEP, which I believe is the Local Area Energy Planning Method, please correct me if I'm wrong, and its growing rollout?
I'm happy to take that one. I mean, we all kind of mentioned, I think, that we're pivoting away from Helen slightly, and also mentioned that Helen has a lot of inputs to take into account. So we never kind of envisaged our Helen persona to ultimately use our digital twin. We always thought that we would want to provide input to Helen's digital twin that she would use for planning, which needs to take a feed from the DNO, as all those other sources that I mentioned earlier. So that's why we've kind of pivoted away from Helen for beta, or we are pivoting away from Helen for beta. That doesn't mean that we are not, we have actually had a session with that team, and we are very happy to interact with them and provide that as an API to still fire off the gas, both the lowest cost path as well as the gas network capacity evaluation and modeling through an API. So that actually works very well for us in that we always kind of built the UI more of as a demonstrator to show how a local authority planner can interact with gas modeling tools, but we'd much rather there be a kind of central planning tool that we just provide an input to, in line with Graham's comments about these connected twins. So we're very happy that the VES team, for example, stated Friday a week and a half ago at their conference that they're looking at a set of connected twins, federated twins, rather than going down the NGSOE route of trying to build a European electricity grid twin kind of as one unit.
Thank you, Owen. Speaking of Helen, does it take into account which fuel is cheaper, electricity or gas to connect?
No, in this case, we assume that Helen wants a gas connection, so we do not do optimization. So that is within Helen's remit, and we are we are looking at kind of potentially similar questions on what we inject into the system for beta, but we're not intending to progress on that for beta as we're pivoting away from the kind of Helen consumption use case.
Thank you. I'm going to jump on to the next one. This is perhaps a wider question. How is this project interacting with other SIF projects to make sure the data standards align in the end product of any outcomes of SIF and could feed into future iterations of this system?
Well, I can continue answering. So we made up the interfaces because they don't exist, but we just, the ESO is part of the team, so we discussed them with them. I'll quote one of our colleagues from the industry. So the Microsoft lead for ENU at the conference actually made a really good point, and that is we're starting to worry less in IT about the syntax of what data, how data is exchanged. We've gotten pretty good at transforming data, and the semantics of that data is more important. So understanding the content of data that we're getting rather than the exact HTML, XML, or payload format of those messages. And that's why we've been having discussions with all of the participants in our systems as to the kind of data that we can exchange. So have we defined a full-blown ontology that defines us all in a lot of detail? No, not for Alpha. For Alpha, we did some demonstrators and we concentrated on the kind of data that we want to exchange. But that is certainly part of our plan for beta, is to start moving that ahead. Graham, do you want to add in?
I just wanted to add, Bethany, for me, actually, also just, this is such perhaps an obvious thing to say, but sharing is key. So I mentioned the white paper that we wrote with ESO. Important to know that in there, actually, we do make reference to things like the adoption of SIM, which I think I've already referenced. We try to respond, if you like, to some of the key headline recommendations in the Energy Digitalisation, Data and Digitalisation Task Force reports. But actually, we've also pushed stuff into the public domain. So just Owen shared the sort of mixed integer programming model and the sort of data structures that we've created to test our concept around H2 production. Well, actually, that's on GitHub. So for actually, it's just about pushing out anything that we produce, anything that we create, anything that we learn, and anything that we've really uncovered over the course of the past 6 months and the previous discovery projects that are connected to this, we've just shared. And that's really so we can use it to stimulate some really fantastic discussion, both as we head into beta, but of course, very much as we hopefully start to move through. And that's there for all SIF projects and active NOA projects to actively take a look at. So hopefully we can have some really good aligned and joined up conversation around that. So for us, sharing is really key here.
Thank you, and it's an important part of the SIF as well. So yeah, data standards is a recurring theme across all our projects, and it's a really important one to address. Thank you so much. Now we've only got 5 minutes left, or just under. I'm going to try and get this meaty one in if we have time. It is a long one, so bear with me. When do we expect to see demand for hydrogen, and what evidence is there for when hydrogen demand will start to ramp up? As today, there is no real significant demand. Very few hydrogen projects have reached FID, the financial investment decision, and very few have passed FEED, front-end engineering design. So what counterfactual cases have been considered against any forecast in hydrogen? And what is the impact on the rest of the system of a counterfactual low hydrogen demand?
So you got the ETO there.
Pete, go on. You start.
Yeah, that's quite a long, challenging question.
It's a chunky one. Sorry about that.
Well, I guess SGN have a whole team, Energy Future teams that are trying to address some of them challenges that you're talking about within that question. I mean, we are launching next year our H100 project, which will supply space heating to homes for 300 homes in Fife in Scotland. That is underway, that is planned. I believe there is a decision this year on the 20% mix of hydrogen into the current gas network system. So all belief is that will go ahead, and our Energy Future teams are preparing plans on how that might ignite the hydrogen economy, I guess. Yeah, and get those big players to market, to start building the hydrogen production plants to feed into the network and other heavy industry, and that heavy industry is going to need hydrogen. Yeah, if it's not natural gas, it will need hydrogen. It's not going to be able to run on electricity. So I guess those things are underway. That's a bit of a waffly answer from me. I don't know if any of the guys back in the office there want to add anything to that.
Yes, so I think one of the things that we're exploring in BEAT is exactly to overcome that problem, is how do you make gas production more, or hydrogen production, but generally gas production, biomethane might come into that mix as well. But how do you make hydrogen production more economically viable? Clearly, our Alex use case of optimizing electricity consumption plays into that. But the other thing is, to what extent can the distribution network act as a sink to take excess hydrogen production that at any given point in time might not be needed by a cluster of industrial consumers. So there's a balancing role potentially that the gas distribution network can play if it can accommodate up to 20% hydrogen. So that's one of the things that we'd be looking at under the themes that Pete mentioned for beta phase. So yes, we recognize it's a problem, and that's why we think having this digital twin is extremely important, because that will allow us to help answer those questions and help support. And that's where we see this as an ecosystem-wide digital twin. This is not just to help the GDN. This is to help hydrogen producers make their business case as well. Graham, were you going to add something to that?
I mean, it's, arguably one of the challenges that we'll undoubtedly face over the course of the next 3 years is, of course, this isn't just, one of the reasons why we're pivoting too is it's not just about hydrogen. So, in our latest energy transition outlook, actually, for the UK that we launched back in December, we did predict that over the course of, the next 10, 15 years, that ultimately energy demand, certainly consumer energy demand, will actually drop, but that's as a result of a certain number of enablers. So if smart energy systems, smarter homes, and just to change that, I guess, in behavioral usage. So, and actually, what does that tell us? It means that actually for our projects in particular, what's going to be really key as we move forward through the next year or so is actually getting closer and closer to those sort of industrial centres, those heavy energy users that Owen's already alluded to, because I guess for us, if we can start to tackle off and cross off, and align with the decarbonation of the approved track 1 clusters, or perhaps the northeast of Scotland, or actually the really challenging one, which is arguably South Wales or the south coast of England, and actually start to work with those and those areas of industry, start to very much progress our process of decarbonising hard to abate sectors. And actually, we're going to hit the decarb and net zero targets perhaps far more quickly than we are by potentially trying to decarb a lot of very, very complex, hard to decarbonize homes in, e.g., the southeast of England. So for us, hydrogen production, the role of the distribution network, the decarb of heavy industry, all powered and enabled through smart systems that can exchange data through the solutions that we've just identified. Really key for industry, really key for our project over the course of the next 3 years.
Thank you all. I'm afraid that's all we've got time for today. Apologies if your question didn't get read out in this Q&A. They will be forwarded on to the presenters, and you will be able to communicate with the presenters as well. So I'm afraid I'm going to have to start to wrap up this show and tell. We have some more show and tell webinars as well. Thank you, Pete, Will, Owen, Graham, and we will speak to you soon. So the next show and tell webinar this afternoon, later this morning, is at 11:15 in a few minutes time for effective renewable integration. And then we have another one later at 2:15 for enabling system flexibility and sector coupling. Next slide, please. So you can stay in touch through a number of different methods. The links are here. Chris has also just put some information in the chat box as well, which you can access. Next slide, please. So round 3 is, we have an event coming up called the Energy Innovation Basecamp, which will be on the 28th of February at the ICC in Birmingham. And it's unlocking energy innovation for a net zero UK power system. There's several topics which will be covered on the day, which are data and digitalisation, net zero transition, optimise network assets and practices, a just transition, and whole energy system transition. So if you'd like to attend the event, the registration link is here. Next slide, please. And I would just like to say a massive thank you for attending, for giving up your time today, and for the presenters. And a massive thank you to the Innovate UK and KTN team for doing all the magic behind the scenes to make this work. And yeah, I'm closing the show and tell for today. Thank you so much.